Alright guys, today what we're going to be going over is how to graph piecewise functions. Alright, piecewise functions, what they are technically two functions that are essentially Frankenstein together. We stick them together, okay? When you're given a piecewise function, you know it's a piecewise function when you look at it like this. Alright, so this is saying f of x. Alright, usually that's y equals. Alright, so y equals 2x plus 3 if the value of x is less than 0. Okay, so this is what piecewise function is. It tells you when it's each type of function. So it's 2x minus plus 3 when x is less than or equal to 0. It's negative x minus 1 when x is greater than 0. Okay, so up here, like normal, you have f of 2, f of negative 6, and f of 0. Okay, what that means is we replace all instances of x with whatever number they show you. Okay, so first it says f of 2. So let's figure out which one we're using. 2 is either, is it greater than, is it less than or equal to 0, or is it greater than x? Well, 2 is greater than 0. Okay, so we know 2 is greater than 0. So the one we're going to be using for this one is going to be this. So we get 2, we're going to use this. Alright, so like always, we replace it in every instance of x with 2. So we get negative 2 minus 1. So this is f of 2. Alright, f of 2. And because it's this one, we're going to be using negative x minus 1. Okay? So, negative 2 minus 1 equals negative 3. Okay, now f of negative 6. Well, f of negative 6, is it less than and equal to 0, or is it greater than 0? Well, we know it's less than or equal to 0, so f of negative 6, we're going to be using this one. So we're going to be using 2x plus 3. So we're going to replace every instance of x with negative 6. So it's going to become 2 times negative 6 plus 3. Alright, which is negative 18, alright, not negative 18, negative 12 plus 3, which equals negative 9. Okay, so that's f of 2, that's f of negative 6. Now let's do f of 0. So, is 0 greater than 0 or less than or equal to 0? Well, 0 is less than or equal to 0, so once again we have to use this one right here. So f of 0 uses 2x plus 3, replace x with 0, so it becomes 2 times 0 plus 3. 2 times 0 is 0, the answer is 3. Okay? That's how you find your f of x, or f of some number using piecewise functions. Alright, so what I want you to do right now is try the try on your own. Okay? Pause the video, try the try, and then unpause the video. Okay. So this time we're using f of 4, f of negative 2, f of 0. So f of 4. So let's see which one f of 4 fits in. Is it less than or equal to 0 or greater than 0? Well, 4 is greater than 0, so we're going to have to use this one right here. So f of 4, okay, is going to be 4 plus 1, because it's x plus 1, which equals 5. Okay? Then you've got f of negative 2. Okay? F of negative 2. Negative 2 is less than or equal to 0, so we're going to be using this one. So we're going to be using negative 4x minus 2. So we replace the x with negative 2. So negative 4 times negative 2 minus 2. So that's 8 minus 2. Which equals 6. Okay. Finally, we have f of 0. F of 0. Alright. F of 0. 0 is less than or equal to 0. So we used the instance of negative 4x minus 2. So it's negative 4 times 0 minus 2. So it's 0 minus 2. So it's negative 2. Okay? That's how you just plug in for the value. Okay? That's all you gotta do to plug in for the value. Now we're gonna get into the actual graphing. All right, the actual graphing is a little bit harder. So let's get into that. Okay. All right. So anyway, let's remember back to our inequality days. Okay. Whenever we have less than or equal to or greater than or equal to, we had a closed dot, remember? All right. And whenever we had greater than or less than, less than or greater than, we had an open dot. Okay. This is going to help us with this. Okay. So first, we're going to know what is our essential line of change. Okay, so where are we changing from one function to another? At what point? Well, it's always going to be on the x-axis. Okay, so right here, you can tell it's going to be at 0. Okay, because both of these have 0. So this is what I'm going to do. I'm going to draw an imaginary line. All right, where x would equal 0. So x equals 0 right here on this thing right here. Okay, so down this whole entire y-axis, the x is always going to be 0. Okay, so right here. All right, so the first one, 2x plus 3. Okay, 2x plus 3. So, what I'm going to have to do is I'm going to have to make two t-charts. Okay? Two t-charts. X, Y. X, Y. Okay? My first t-chart is going to deal with the first one. Okay? Second t-chart is going to deal with the second one. Okay, so in both of these, one of my points has to be 0. So both of them, one of my points has to be 0. And my second point, okay, my second point can be anything you want, except for the first problem. Since this x is less than or equal to 0, the number has to be less than 0. So we'll use, I don't know, -1. And in this one, the x has to be greater than 0. So I don't know, we'll use 1. All right, just for easiness. Okay, so let's plug this in. -1 goes into, okay, so -1 goes where the x goes. Okay, so this is how you do a t-chart. -1 goes where the x goes. Okay, 2 times -1 is -2. -2 plus 3 is going to be 1. Okay, so -1, 1 is 1 point. Now let's do the next one. 2 times 0 plus 3. 2 times 0 is 0, plus 3 is 3. And 0, 3 is the second point. So the first point is -1, 1. Okay, so we're going to find -1, 1. And we're going to put a little dark mark. Okay, now, the next one is, remember, this is where, at 0 is where the thing goes from one type of function to the other type of function. So we got to look at this. This first one is a less than or equal to sign. So this top function has the closed dot, while this bottom function has the open dot. So this one has the closed dot, this one has the open dot. Okay, this one has a line under the inequality, this one doesn't. So wherever I see 0 on my first x, y, t chart, I'm going to put a closed dot. So it's at 0, 3. So I'm going to find 0, 3 and put a closed dot. Okay, and then I'm going to essentially make a line. All right, I'm going to make a line. Okay, now there's a reason why this line never crossed the y-axis. Okay, this is called a piecewise function because essentially this line of change, this invisible wall right here, stops the function from moving to the other half of the graph. So this stops the function moving to the other half of the graph. Okay. So let's try to figure out what the second one would be. So 0, if I plug 0 in for x, it would be -1, which equals -1. Okay? The other ones plug 1 in, so negative 1 minus 1 equals negative 2. So it's 0. 0, negative 1. That's my first point I'm going to graph. So once again, because it's on the line of change, alright, we're going to use an open dot since we're using this one. So we're going to use an open dot at 0, negative 1. So 0, negative 1 is going to have an open dot. Okay, open dot. The rest of them are going to be closed dots. So 1, negative 2, 1, negative 2, closed dot. Connect the two dots. And there you go. That is what's known as a piecewise function. Okay, so let's try another one. Okay, once again, we're going to make two t-charts. Our line of change, once again, is where x is 0. So it's along this x-axis. Alright, this is our line of change. Okay, it's going to be a line of change. So we have our xy t-charts. X, y, x, y. Alright, so once again, we have to have 0 in both of them. I'm going to use a point for the first one. It's going to be below x, or below 0, which will be negative 1 again. Use a number above x, we'll use 1 again. So this is negative 4x minus 2. This is x plus 1. So when I plug in negative 1 for this, I get negative 4 times negative 1 minus 2, which equals, alright, this should be 4 minus 2, which is going to be 2. And then let's put the next one in, 0, so it's negative 4 times 0 minus 2. Negative 4 times 0, 0 minus 2 would be negative 2. So our 2 points are negative 1, 2, 0, negative 2. So once again, let's graph these. Negative 1, 2, negative 1, 2, dark mark. Alright, this one has the closed dot. This one has the open dot at the line of change. So when I see 0, negative 2, I'm going to find 0, negative 2, put a closed dot, connect the two dots together. Remember, you can't go on this side of the line of change. Okay. So the next one. So we've got 0 plus 1, which equals 1. Then we've got 1 plus 1, which equals 2. So 0, 1 is my first point. Remember, since it's x plus 1, we have the open dot at the line of change. So we're going to do 0, 1. So 0, 1, open dot. Okay, that's going to be open dot. 1, 2. 1, 2. It's going to be closed dot because it's not in the line of change anymore. And that is what a piecewise function should look like. Okay? Alright, you're going to try the you try by yourself. This time the line of change is at x equals 2. So please try that out and see what you get. Alright. Now, this time, line of change is where x equals 2. So this is my line of change right here. Right here. Okay, my line of change is right there. Now, this does not have the, so this one's going to be the open circle. This one has a line under it. This one's going to be the closed circle. Let's make our x, y, t charts. X, y. X, y. 3x minus 5. So once again, 2 is the line of change, so I'm going to use 2 in the thing. 2 in the thing. This is x squared. Alright. This one is a line still, so I'm going to use 1 below it. This one's a parabola, so let's use, we can use 2. Alright, you don't have to do 2 if you know what a parabola does, but we'll do 2 just in case. So, 1, let's plug it in. 3 times 1 minus 5. 3 times 1 is 3. Minus 5 is negative 2. Okay. So then we got 2 times, or 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. Okay, so this one's 1, negative 5, 2, 1. Let's see the other one. Okay, so it's x squared, so it's going to be 2 squared, 3 squared, 4 squared. This equals 4 equals 9 equals 16. Alright, so let's graph this. First point, 1, negative 2. So 1, negative 2. Okay. Remember, this is the open circled one. We're using the open circled one on x is less than 2. So 2, 1 is my next one. So 2, 1. Oh, it's going to be an open circle because this one has the open circle. Connect the two. The next one, all right, it's going to be at 2, 4. So 2, 4. It's going to be closed dot. 3, 9. So we're going to go 3, 9. All right. I can't really put 4, 16 on there, so I'm just going to draw this. So this is a parabola, so it makes a little U-shaped thing. So it goes like that. That is the piecewise function. We're going to work on that a little bit more in class. All right, the next thing, vertical and horizontal shifts. Vertical and horizontal shifts. So we're going to deal with the 4 basic parent functions, okay? 4 basic parent functions are this, okay? Straight lines is usually y equals x, okay? That's a parent function. What a parent function means is that it's essentially the original function. Without adding any numbers or anything into the equation, it's what it would look like without all that mumbo jumbo, okay? This one is a parabola. Y equals x squared is the parent function. So y equals x squared is the parent function. All right, it's what everything branches off of it. This is what is a root. So this is y equals the square root of x. And finally, this one is known as a absolute value. So it's y equals the absolute value of x. These are all the parent functions that we're going to be dealing with. Okay. So, y equals x, y equals x squared, y equals the square root of x, y equals the absolute value of x. Okay. Alright. So, we are going to first try the vertical shifts. Okay. Vertical shifts. What are vertical shifts? Are moving the thing up and down. How we do that is, if you notice, the parent function is y equals x. To move something, you just add to the parent function. That's all you got to do, is add to the x value of the parent function. So we have y equals x plus 3. So all we got to do is move every point up 3. Okay? So this makes it move up and down. So vertical shifts, all right? When you're adding, you're moving up. When you're subtracting, you're moving down. Okay? When you're adding, you're moving up. When you're subtracting, you're moving down. So, all these points, they move up 3. 1, 2, 3. Okay? This point goes up. 1, 2, 3. This point goes up. 1, 2, 3. Okay? This makes a line. You can see I shifted the line up 3. So I'll leave that there for a second. Alright, so the next one. Alright, this one. So the original parent function, alright, this is the original parent function right here. Alright, it is y equals x squared. Y equals x squared. What it wants is to make a vertical shift, -4. Remember, minus means moving down. So we're going to move every point down 4 units. So this point right here goes down 1, 2, 3, 4. This point right here goes down 1, 2, 3, 4. Down 1, 2, 3, 4. This goes down 1, 2, 3, 4. All right. Then we have a new parabola of a vertical shift right here. Okay. That's a vertical shift. So you're moving it up or down. Now I want you to try the U-tries by yourself. All right. These are the U-tries. You should have done these by yourself. Now this is, the parent function is square root of x. We're adding 1, so we're shifting everything up 1. So this point goes up 1. This point goes up 1. This point goes up 1. Okay? So then you connect the dots. Try to make it look as much as like the parent function as possible. X squared minus 3. Once again, that means shift everything down 3. So we go down 1, 2, 3. 1, 2, 3. 1, 2, 3. So on and so forth. Okay, those are what are known as vertical shifts. Now let's get into horizontal shifts. Okay, horizontal shifts. Now, horizontal shifts, you can tell the difference between a vertical shift and a horizontal shift pretty easily. Horizontal shifts just add or subtract to the original function. Okay? Alright. Horizontal shifts, they actually go in between the signs. Like, see how it went from x squared to x minus 4 squared? This went from x to x minus 2. These are horizontal shifts. Okay? So, when you subtract, you go right. When you add, you go left. Okay? Subtract, go right. Add, go left. Alright, so this one is going from x to x minus 2. So minus means to go right 2 units. So it's going to go right 1, 2 units. It's going to go right 1, 2 units. It's going to go right 1, 2 units. This is a horizontal shift. Okay. Once again, this is inside the parentheses, so this is a squared. Okay. So leave that for you. Type it down real fast. Let's go to the next one. All right, x minus 4. X minus 4. So that means minus. We're going right. Okay, minus going right. So that means move everything to the right 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Horizontal shift. Okay. Finally, you get to the U-try. Okay. So, it's inside the square root. Remember, if it is outside the square root, okay, outside the square root is a vertical shift. Inside the square root is a horizontal shift. You're adding, so that means you need to be going left. We go left, 1, 2. We go left, 1, 2. We go left, 1, 2. And that is our horizontal shift. So, x plus 1, it's inside. Okay, so this is a shift to the left. Everything shifts to the left, 1. Okay, so copy both of those down. Remember, adding shifts left, subtracting shifts right. Finally, to flip a graph about the x-axis, we need to make the equation negative. All right. Now, when I say making something negative, that doesn't necessarily mean that it has a negative sign. Negative means to essentially switch the sign. So change it into the opposite sign. This means that the reflection of f of x is g of x if g of x is equal to negative f of x. All right, all that means is that if we change the sign, we can flip the graph. Okay, if we change the sign, we can flip the graph about the x-axis. All right, this is the x-axis right here, guys. Okay, this is the x-axis. So if I were to flip this, okay, if I were to flip this, what I would have to do is make this positive. Okay, if I made this positive, I would flip the entire graph. That means that this point, which is at 2, flips to be negative 2. Okay? This point right here, which is at what looks like negative 1, would flip to be positive 1. This point right here, which is would flip to right here. Okay? Notice, it flips the graph upside down. Okay? It flips the parent function, or it flips the graph upside down. And that's what it means to have a flip, okay, is to change the sign in front of the thing, in front, okay? All right, we'll go over this a little bit more in class, but that's all the notes. And that's the end of the section.